If we look at the U.S. Geological Survey hazard seismic areas map for damaging earthquakes, the West Coast looks like about what you'd expect, with the highest threat category including sections of the San Andreas Fault, Walker Lane Province, and then areas at the highest risk of potential megathrust earthquake shaking on the west coast north of Cape Mendocino. General seismic hazard subsequently largely decreases as you head east, until you reach three eastern United States regions which are unexpectedly at higher risk. From west to east they are called the New Madrid Seismic Zone, the Eastern Tennessee Seismic Zone, and the Middleton Place-Somerville Seismic Zone. Two of these three provinces produced at least one damaging magnitude 7 earthquake in historic time, while the middle of the three produced at least one such earthquake of comparable magnitude around 20,000 years ago. The earthquake which struck on May 10 occurred within the East Tennessee Seismic Zone, specifically at the very edge of the zone shaded red and orange. The earthquake had, like many historic earthquakes in the East Tennessee Seismic Zone, struck at intermediate depths in the crust of around 15.5 miles or 24.9 kilometers below sea level. You might think if you live nearby, especially in Tennessee, earthquake comparison, that this specific earthquake must have been the largest to occur within this seismic zone in a fairly long time, right? Surprisingly, no. The May 10 earthquake wouldn't even rank in the top 10, coming in as the 17th largest earthquake to strike the aforementioned seismic zone since 1850. In other words, an earthquake of the same or larger magnitude strikes the East Tennessee Seismic Zone, which for reference ranges from the very eastern portion of Mississippi all the way to the southwest portion of Kentucky about once every decade. This zone produces the second highest abundance of earthquakes east of the Rocky Mountains in the contiguous United States, producing around 800 earthquakes a year, almost all of which occur at intermediate depths. It just so happens that most of these earthquakes are far too small for anyone to feel. Saturday's earthquake involved the movement of a strike-slip fault, and while strike-slip fault, there are two plausible solutions for the movement which occurred. It likely happened on a west-to-east trending left lateral strike-slip fault. Now, here is where it gets a little weird. Despite the largest historical earthquake in this province being a magnitude 5.1 that struck Alabama, some sources claim that earthquakes in this zone could theoretically reach up to magnitude 7.5. Yet, this seismic zone doesn't seemingly involve a single large fault line. Instead, it seemingly involves two clusters of fairly parallel smaller fault lines, with multiple of these sometimes simultaneously moving in distinct earthquakes. While there clearly is a heightened earthquake hazard here, we can't agree yet on why exactly the East Tennessee Seismic Zone exists. However, New York lineament, what can be agreed is that these faults appear to be quite old reactivated faults which are accommodating some sort of distant or localized stresses. Possibly, they might even specifically be related to an ancient weak zone in the crust created due to the Grenville orogeny which largely occurred 1.1 to 1.0 billion years ago. This left behind a series of large strike-slip faults that are today known as the New York-Alabama lineament. Currently, while in all likelihood one or more aftershocks will occur, the expected statistical largest aftershock will be a 2.9, and the odds of a larger damaging earthquake are absurdly remote. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.